Today we're talking about real-world quantities, and our learning goal has us solving word problems in forms of equations. So it gives you this equation form: px plus q equals r, and p times x plus q. Both of those equations are things that we've seen before, especially the second one. It might remind you of the distributive property. The first one is really what we call a one-step equation. And one-step equations typically have one variable, and they're fairly simple to solve, right? You'll probably only have to do one step to really get the solution correctly. So some of the equations that we're going to look at have to do with one-step equations and distributive property. Firstly, on the top of your page, you should have this area and perimeter template. A lot of one-step equations have to do with area and perimeter. They have to do with finding a missing area or a missing perimeter or a missing side length. All of these things are important. This is just a nice visual for you to remember what is area and what is the perimeter. Remember, area is the space that fills up a shape, and perimeter is the distance along the outside of the shape. So we're not doing any area perimeter problems today, but just so that you have that visual in your head and helps keep you fresh when we're doing some in class next week. The first problem that I do want to talk about is this one right up here, and it says, I think of a number, I double it, and add 12. My answer is 54. What number am I thinking of? Well, we are going to write a one-step equation to mimic this situation so that we have something to go off of. So, first of all, it says right here, my answer is 54. So I'm going to start with that. My answer is 54. Right? You can kind of see how that's one side of the equation, and the other information should be the other side of the equation. So we're thinking of a number, and since we don't know what that number is, we're just going to call it x. It asks you to double the number. You can do this a few ways. You can add a second x, or what I prefer to do is you can multiply your x by 2. So instead of having one x, you have two x's. And then it asks you to add 12. So I like to go through my problem and underline or circle any of the information that I think needs to be in my equation so that I can go back and check that I included it. So I included a number, x. I doubled it by multiplying by 2, and then I added 12. And I knew that my solution was 54. So all those things I did, in fact, include in my equation. Now it says, what number am I thinking of? So the question's really asking you, what is x? You might have to reach way back in your brains to remember how we did some of these before March break. When we're trying to figure out what x actually is, we're trying to isolate the x or get it by itself. So we need to work backwards, and we need to try and remove the pieces that are not attached to the x first. So some of you may remember Pemdas. Please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. That's the order that we solve equations, but since we're solving for x, we're kind of doing this backwards. So if I start at the bottom with subtraction or addition, the piece of my equation that has to do with subtraction or addition is the plus 12. And I want to remove that from the left side of my equation, so I'm going to turn it into a 0. I'm going to use the identity problem, the identity property, and subtract itself. 12 minus 12 equals 0. So now that 12 has been removed from the left side of my equation. I also have to remove the 12 from the right side of the equation so that it stays balanced. So 54 minus 12 is 42. So my new equation is 2x equals 42. I remove the 12 from the left side, I remove the 12 from the right side, and this is what I have left over. 2x also means 2 times x. So if I have 2 x's that equal 42, what is 1x going to equal? Well, I could find that out by dividing. Divide both sides by 2. And again, thinking about Pemdas, we're working our way up. We're kind of working backwards. And we're going to use that division tool. So 2 divided by 2 is 1. 1x is the same as just x. 42 divided by 2 is equal to 21. So the question, what is x? Well, x is equal to 21. Now, you can definitely check your answer in these types of problems, because when I go back and look at my original equation, I could think to myself, if x was 21, is 2 times 21 plus 12 equal to 54? Well, 2 times 21 is 42, plus 12 is 54, so that is correct. So I know definitely that I have the right answer. Moving on, the second example says Anna owes her parents $54. She decides to pay back this money at $6 each week, and after some weeks, she has paid back $6 too much. How long has she been paying back the money? So in this case, I have the amount, $54, and I know I need to pay it back at $6 at a time over the course of some number of weeks. I don't know how many weeks there are, but there's some number. So I'm going to use the variable W to represent weeks, and for every week she's paying $6. So at 1 week she's paying $6. At 2 weeks she's paying $12. At 3 weeks she's paying $18. So I need to be able to multiply the number of weeks by $6 to get an accurate sense of at how many weeks will I pay back $54. Except there's a trick in this problem. It says at some point she's paid back $6 too much. So not just the $54, but $6 in addition to that. So now I can solve my problem, which says how long has she been paying the money back? How long has she been paying the money back? So what it wants to know is the number of weeks, right? Again, I'm going to use a similar technique by starting at the bottom of my Pemdas, or my order of operations, and looking at the addition. 54 plus 6 is 60. 60 equals 6 W's. If 6 W's equals 60, how much does 1 W equal? Well, 6 divided by 6 is 1, or 1 W, so that's just a W. 60 divided by 6 is 10. So 10 is the number of weeks that she's been paying the money back. Again, we can go back into the problem and double check that we're correct. Does 6 times 10 equal 54 plus 6? Well, 6 times 10 is 60. 54 plus 6 is 60, so we are, in fact, correct. The number of weeks that it takes her to pay back is 10 weeks. The last problem that we're going to look at is a little different. It actually has you tracking time. So it says the temperature outside is dropping at 3 degrees per hour. Given that the temperature at noon was 0, what was the temperature at 1 p.m.? What was the temperature at 2 p.m.? What was the temperature at 3 p.m., at 6 p.m.? And what's the temperature T number of hours after noon? So here's the trick. When we're measuring time in this scenario, we want to measure it as hours after noon, or 12 p.m. At 0 hours after noon, it's actually 12 p.m. At 1 hour after noon, it's 1 p.m. 2 hours, it's 2 p.m. See? So 3, 4, 5, 6, and then we're going to go to T hours. So the temperature at noon is 0 degrees. It drops 3 degrees per hour. So at 1, it's -3. At 2, it's -6. At 3, it's -9. And we can continue on with our pattern. Whoops. Until we get to the T, because of course we don't know what that means. So the question asks, what was the temperature at 1, 2, 3, The temperature at 1 is -3. The temperature at 2 is -6. The temperature at 3 is -9. 6, so at 6 p.m. the temperature is -18. And then it says, what's the temperature at T hours afternoon? Well, we're going to look for our pattern here. To get from the 1 hour at 1 o'clock, or we'll start at 0. At 0 hours from 12, the temperature is 0 degrees. So these are equal to each other. At 1 hour, the temperature is -3 degrees. So if I multiply 1 times -3, I get that -3 degrees. 2 hours afternoon, it's -6. Again, if I multiply by -3, I get -6. I can continue to check this pattern and see that 4 times -3 equals -12, 5 times -3 equals -15, and so on. So the temperature, T hours afternoon, must be T times -3. And that T just represents the number of hours. So if we were 20 hours after noon, then -3 times 20 would be -60. It would be -60 degrees outside. Of course, it's very unrealistic, right? Some of these problems that are recursive like this make us think that we have the incorrect answer because it just doesn't make sense. But when you think about temperature continuing to decrease, you know it's always going to increase inevitably, right? So lastly, make sure that you're doing your learning goal, your what I know, what I learned, and your proof. Your proof is a multiple choice problem. It just asks you to identify the right equation, which describes the story in the problem. So it's really important for you to have all those components of your journal, especially your reflection. Seeing as we have not done a journal entry in a little while, I just want to make sure that you are aware of your expectations.